Dilation and similarity. This is going to be an awesome, awesome topic, and I'm really excited for it. So let's get started. First example, dilation of 4 about the origin. Now, about the origin is going to be standard, so you don't need to worry about that until you're probably in 10th grade or so. Anyways, dilation of 4. The factor 4 tells you how much to dilate the object. If the number is greater than 1, it's going to be a lot larger. If the number is less than 1, it's going to be a lot smaller. So let's get it going. How do you start? You need to know the coordinates of this shape. So we're going to start with the coordinates F, G, and E. So coordinate of F is 1, 1. Coordinate of G is -1, 0. And coordinate of E is 0, -1. Because it went down 1, so 0 on the x-axis, 1 down on the y. Okay, and now we know that it's a dilation of 4. Here's a trick. That means every single number you see here will have to be multiplied by 4. So you can kind of write it down times 4. And this is what you're going to get. Okay? This is what you're going to get. So if so F prime, G prime, and E prime. Look at that. 1 times 4 is 4. Then another 1 times 4 is 4. That's your next point, 4, 4. So let's go ahead and find it. 1, 2, 3, 4. 1, 2, 3, 4. This is the point 4, 4, or my F prime. Okay, you see how far this went. Now, good things are going to happen. Just wait. Now, G was -1, 0. So -1 times 4 is -4, 0 times 4 is still 0. And finally, E, 0 times 4 is 0. And -1 times 4 is -4. Let's plug them in right now. So my G prime is -4, 0. So -1, -2, -3, -4, 0 is going to be my G prime. And E prime was 0, -4. -1, 2, 3, 4. So this is my E prime. And guess what? Now, when you connect the dots, now I'm a professional. I can do it without a ruler, but you don't try this at home, okay? I'm so-called professional. And here you go. There you go. And nice. Look at that. Look at the larger triangle matches the smaller one. But this is like a scaled up version of it. That's cool. Now, let's take a look at the example 2. Dilation of 1/2 about the origin. Here we're dealing with 4 points. Okay, so 4 points. If this one was, I was, let's say, number 1, now we're going to go for number 2 example. Again, in here, you need to come up with 4 vertices. G, H, I, and F. Order of those doesn't matter. You can start anywhere you want. I just go in from top to kind of counterclockwise. So now let's go with G. Coordinate of G, first coordinate is -1. Then next coordinate is 1, 2, 3. So it's going to be -1, 3. H is 2, 2. I is 0, -3. And F is -1. -2, -1. And then we have a dilation of 1/2. Or I could say 0.5, okay? If you use a calculator for that, which you guys will be able to use a calculator. And so we multiply it by 0.5. And notice I use in this example, I'm just going to use a dot. This was like a X, old school multiplication. This one is just dot times 0.5. Could put an arrow in there. You don't have to, but just for the sake of consistency, you can follow exactly as I have it. So GHIF, okay? So these are my 4 points. 4 new points, they're all primes. And now I'm going to have to use a calculator. Okay, you can use a calculator now if you want to, but I'm going to use a calculator. All right, that was a joke. Now, let's go ahead and multiply -1 times 0.5. I already know the answer is -0.5. Okay, comma, 3 times 0.5. I know this, I'm going to show you right now. 3 times 0.5. The answer is 1.5. So I'm going to put it right here, 1.5. Now, h, 2 times 0.5 is 1, comma, 2 times 0.5 is 1. Now, I, 0 times 0.5, it's easy, is 0. And -3 times 0.5, well, guess what? We already did 3 times 0.5 is 1.5. So -3 is the same thing, but with a negative in front of it. Now, this one, 2 divided by 0.5, or 2 times 0.5, 2 divided by 2 is -1. And this one is going to be -0.5. A lot of decimals, a lot of small numbers. So now let's go ahead and plug those in. So g prime was -0.5, comma 1.5. So now -0.5 is right here, half. 1.5 is going to be, is going to be 1 right in here. So my g prime is this dot right here. See, it's not directly on any of the intersection of these coordinates, is somewhere in between them. Okay, so this is 1.5 and this is -0.5. Yes, you guys will see a lot of those. You can zoom in. I don't have a function to zoom in on my paper, but you can zoom in and you will see that on the computer, and you will see that if you're working with the appropriate software. Now, 1, comma 1, that's pretty straightforward. So this is what my h prime is going to be. H prime is 1, comma 1. Now, I prime is 0, comma -1.5. So we're going to go 0, comma -1.5. Right here is going to be our, wait, is it I prime? Yes, it's I prime. So here we go, I prime. And finally, f prime is -1. -0.5 is right here's the f prime. Okay, so here you are. We got 4 points, and now we can connect them. So I'm going to use a different color. I'm going to use a blue just to contrast what's happening here. Okay, here you go. And my blue looks just like my regular marker. So here you go, connect, connect, and look at that. Now you get a shape twice, half the size of the original one. Okay, so it's twice as less, or half of the size of the original one, which is pretty cool. Okay, and example number 3. It says find the coordinate of the vertices of each figure given after the given transformation. Well, to be honest with you, you gotta do the same process, okay? And you're gonna have to find coordinates of every single one of these. So here you go. Example 3, I'm going to do the same thing I did in previous examples. Dilation of 1.5. So that's our scale factor. So again, I, H, and J, and here you go. After you multiply every coordinate here by 1.5, here's what you're going to get. And these were the examples, first 3 examples. You don't need to graph example 3. It didn't say to graph. It just says find the coordinates of the vertices, and these are the vertices. And here you go. All right, so once you multiply, use a calculator for that to speed up the process. And there you go, 1.5 times -1 is -1.5, and so forth. So that's how you get from these coordinates to the prime coordinates. Example 10. Now we're talking about proportions. So you got the question, r divided by 2 equals 8/9. And let me give you a trick to solve the proportions. You can say that the product of outer terms equals the product of inner. What does that mean? Oops. Product of outer equals the product of inner terms. What does that mean? Well, let's write it as r divided by 2. That's because that's what r over 2 is, equals 8 divided by 9. So the outer terms are the ones on the outside, and the inner terms are the ones on the inside. So we're looking at r times 9. It's going to be essentially the same thing as 2 times 8. This is a property that was discovered many years ago, and I don't want to go into proof of that. So we're just going to take it as a proper rule. So we can actually write down as, actually right here, check this out. So you can kind of go like this, the cross method. So it's r times 9 is the same thing as 2 times 8. All right, and we can just rewrite it as is. So it's going to be r times 9 equals 2 times 8. And now, whatever we can do, you do first. So r times 9, well, I don't know what r is, so I cannot do anything with that. But I do know that 2 times 8 is something nice. So I know that, I'm going to write it right here. So r times 9 equals 2 times 8, 16. r times 9 equals 16. So now what you do is to undo multiplication. To undo multiplication, you divide. So we're going to divide both sides by the same number. We're going to divide both sides by 9, because this way, these two 9s cancel out, leaving just 1 over 1 after themselves. So we're just going to write down this is just r equals, and 16 divided by 9 is, I'm going to use a calculator. I'm going to take some time and use a calculator and show you. So 16 divided by 9 equals 1.777 repeating. So it's going to be 1.7 repeating. And that's my answer right here. R equals 1.7 repeating. Okay? So that's question number 10. Question number 11. Question number 11 is done in the same key. So I'm going to write down right here, number 11, and it's written something like this. 8 over 9 equals 4 over n. Same rule applies. When you're solving proportions, the product of the inner ones is the same thing as product of the outer ones. If you want me to write it like 8 divided by 9 equals 4 divided by n. And that's when you want to do, if you want to connect the outer ones first, okay, the 4 and the 8 and n, and then the inner ones, the 9 and 4, you can do that. Or you can just simply either circle them or draw the arrows towards them. You can, that's also acceptable, okay? And so here we go. Let's go ahead and do it. So the product of 8 times n equals 9 times 4. Again, I don't know what n is. I need to find out what it is. So I'm going to leave it as is for now. So it's going to be 8 times n equals, and I know that 9 times 4 is 36. Use a calculator if you don't believe me. You can check it out yourself. So now, what times 8 equals 36? Well, I don't know that, so I'm going to go ahead and get rid of 8 on each side. So on this side, 8s are gone, leaving just n by itself, n equals 36 divided by 8. Again, let's use a calculator. Okay, 36 divided by 8 is equals to 4.5. N equals to 4.5, and that's the end result. Now, this segment is about similarity and similar figures. You might be asking yourself, why did I do these problems? And what's the point of doing proportions? And here's the answer. We're going to do proportions in order to figure out the similarity between the two shapes. So number 20, sorry. You're looking at two shapes. One is triangle that you know. Usually the small triangle, you know, it's the model. And now you're going to predict what the larger triangle is going to be like. So in here we got a couple of different ways to find it. So you're looking at a small triangle. This side is 7 and the base is 11. And then you have a larger triangle. You know that the base is 22 and perhaps you can't measure this side because it's too tall, too much. You don't have the tools to do that. But you do know that the triangles are essentially the same shape. So here's how you do it, okay? You compare the known sides. For instance, you can do either 22 compared to 11. So there's multiple ways of doing it. So I'm going to start with 22 compared to 11, or 22 divided by 11. Why? Because we chose to start with a larger triangle over smaller triangle. With the same thing, we're going to use this side equals x over 7. So 22 relates to 11 as much as x relates to 7. And guess what? Now we have a nice proportion. Just like we did before, 22 over 11 is x over 7. So that's our proportion. So what we can do is we can go, well, guess what? 22 to 7 is the same thing as 11 to x. So here you go. Now, what you do is you multiply 22 by 7, okay? And then you multiply 11 by x. So again, 22 times 7 equals x times 11. And again, 22 times 7 might be too much for me, so I'm going to go 22 times 7, and I'm getting 154. So right here, I'm going to write down 154 equals x times 11. Well, what do we do next? Next, we divide both sides by 11 because I need to find what x is. And 154 divided by 11, I'm going to go divide by 11 equals 14. So 14 equals x, or x equals 14. And that's it. So you can kind of see now I can put 14 in here. That's my x. I already found it, which is super nice. Okay, and you can actually see that 22 is twice as much as 11. So 14 has to be twice as much as 7. So essentially, the coefficient, I'm going to put it k, equals 2. So basically, whatever all the sides of this triangle are, you multiply them by 2 to get the sides of this triangle. And so there's another way of doing it, not another way, but if you choose to do it some other way, for example, we're still number 20. Pretend for a second you don't know that this is 14. Going back to the initial problem, you're looking at, say, if you didn't want to do 22 over 11, you can do 22 over x, but at this time we have to do this. 22 over x is the same thing as, so base over side is the same thing as base over side in this triangle. So it's going to be 11 over 7. And we're going to do the same thing previously. So 22 times 7, and guess what? Equals 11, equals x times 11. And the result is going to be the same as the previous one. You know that 22 times 7 is 154, x times 11, and 11 times x are essentially the same thing. All right, so that's one. I'm not going to go into details of that. Also, what you can do is you can start with this triangle, with a small one. You can say 7 to 11, relationship of the sides, 7 to 11 is the same thing as 7 to 11 is the same thing as x to 22. We can write down like this, x over 22. That's doable as well. And guess what? If you try to do this proportion again, 7 times 22 is the same thing as 22 times 7. And 11 times x and x times 11 is going to be exactly the same thing, and the answer will come out to 14. So there are at least three different ways that I just showed you, and there's many more than that. Okay, there's many more choices than I just showed you. So that's how you do question 20. The answer is 14. And question 21. So if you look in the question 21, it's going to be the same thing, but this one I kind of want to do it a little different. I want to do it through coefficient. To find coefficient, like I did before, again, by the way, you can do it as proportion as well. Okay, easy. But I kind of want to do it through a coefficient. So I want to see how much larger is the first quadrilateral than the second one. So I'm just going to compare the corresponding sides, which are 24 and 4. And I'm going to do 24 divided by 4. I want to see if it's a nice number. So what's our constant? So 24 divided by 4, okay, so 6 is right here, so equals 6. So our k equals 6. So this triangle to that triangle is going to be 6 to 1. So if I divide 24 by 6, I'm going to get 4. If I divide 30 by 6, guess what? 30 divided by 6, I'm going to get 5. So I know that x equals 5. So this side is 5. Does that make sense? Yes, it does. Look, 24 and 30, they're quite similar to each other in terms of the quite large numbers. 24 is close to 30. And look at that, 4 and 5 are much smaller numbers, but they're also proportionate. So that's one way of doing it. If you like the first method, without finding the constant, let's go ahead and do that as well. So right in here, I'm going to write down question 21. All right, so 21. Number 21. And let's compare sides. Again, 24 I want to compare to 4. 24 over 4 is the same thing as 30 over x. If you like it this way. So again, 24 times x. Okay, we're doing the x method. Equals 30 times 4. Again, I can't do anything with 24 and x, so I'm going to leave it as 24 times x equals 30 times 4. And 30 times 4 is 12, so it's going to be 120. And now we divide both sides by, well, we don't know what x is, but we know that there's 24 attached to it. So if it's 24 times x, if there's multiplication, to undo it, you do division. So divide both sides by 24. You want 24 to disappear from the left. And let's see, 120, divide that by 24. So x equals 5. And there you go. So I just found out x equals 5 using multiple methods. If you want to go through coefficient, see, okay, this is larger by, this is like 6 times. That's quadrilateral. Go for it. If you want to do it the coding method, you can do it as well. Now, this segment, similarity proportional parts, is going to be by far the most exciting and the most challenging. So if you need to review proportions and the previous videos, I'd say pause the video, stop the video, rewind it back, watch it again, get the mastery of the content before you try these ones, okay? It's going to be exciting, but it will require you to think beyond the box. So let's try it. Question 34, it says, find the missing length indicated. I'm going to show you a couple of tricks. What I do is you almost must rewrite the triangle, okay? Redraw a triangle. Actually, there's not just one triangle. There's a trick question. How many triangles do you see? There are 2 triangles, okay? So got 2 triangles. So one is the smaller one and one is the larger one, and they are similar. So what I would do is I want to be a little exaggerating, so I'm going to write down a smaller triangle, okay, and then looks like a quadrilateral. So there you go, that slice of pizza, and then there's going to be a larger triangle, and I want to make sure that the larger one is you know which one is larger. Okay, it's okay to exaggerate things a little bit. And now let's take a look at that. So if you see this markings, okay, that means that it's the length described here is the length of the entire side. So this side is 6. And then again, larger triangle side is 12 here. So we know the dimensions of the large triangle, and they are 6 and 12. Now, smaller triangle, you don't know any side because, first of all, the question mark simply will put means that that's the x. So I'm going to put it right here. How do you know which side is x? Is x the whole side, or is x just the this side right here, the one that I highlighted? Well, if there are marks right here, you see the arrows pointing, that means it's the whole side. So the entire side is going to be 6 and 12. Those are the larger ones. And the ones that don't have those arrows, that means that they represent smaller sides. So again, I separated these two triangles into two. I rewrote smaller one right here and the larger triangle right here. Okay, so again, repeating myself one more time. 6 and 12 are the lengths of the large sides of the larger triangle. Question mark simply means x. And now, here's the game plan. Here's a game changer right here. You see this little 1. Okay, this side is equal to 1. If this side equals to 1, that's nice, but we need this side. And that side is, guess what? The whole thing is 6. This side is 1. Guess what? This piece right here is 1. The side of a smaller triangle is equal to 5. How did I get 5? Because this 1 plus 5 equals 6. So the smaller side is going to be 5. At this point, the toughest portion is done. We have two similar triangles, and you know that one side is 6, one side is 5, this is x, this is 12. Now it's time to create a proportion. And here's how I would do it. To create a proportion, you can go either way you want. You can compare x to 12, x to 5, 5 to 6, that kind of stuff. So I'm going to go ahead and create a proportion like this. X over 12. Okay, I'm going to compare the larger sides. So it's going to be x compared to 12. Is the same thing as 5 compares to 6. Well, now back to proportions. 12 times 5 and x times 6. So 12 times 5 equals x times 6. 12 times 5 is 60 equals x times 6. And now to solve for x, you do division by whatever is attached to x. In this case is 6. So divide by 6 both sides. And you're going to get divided by 6, 10 equals x, or x equals 10. And last example, example 35. If you get this problem, you're ready to go to Harvard. So you're looking at this shape right here, this intersection of 3 parallel lines going horizontally, and there are 2 transversals. One go one way, one go another way, and a bunch of numbers right here. So we can this numbers right here and see that 5 and 4. Let's take a look at the bigger sides first. So I know one larger side is 18. So you know the combination of these two sides is 18. And you know that the combination of these two sides is going to be, I'm going to go draw arrows like this. 5 plus 4 is 9, because this side plus that side equals that side. All right, so now let's take a look at that. You have 18, you have 9, those are the parts of the larger shape, and then you have this x right here. So what do we do? Again, just like in previous problem, I would like to separate the shapes into separate ones. So for example, we gotta look at these quadrilaterals, and I'm gonna go and write down what I know. Smaller one, I'm going to call it the quadrilateral S, so you know that this is a smaller one. This is 5, and this is X, okay? And now the larger quadrilateral, I'm going to go ahead and use blue color for it. It's going to be 9, as we determined already, and 18. And I'm going to call it, well, I'm not going to call anything because I don't want to overlap my drawings, but you get the picture. So this blue one, I'm going to go ahead and highlight for you. So this is the blue one, and the S is the small one. Now I want you to kind of pause it for just a second and see how I got those numbers. All right, how I got those numbers. So the S small one is already given to me. Okay, is already given to me. I didn't do anything to discover it. It's right here. I'm going to shade it. I'm going to shade this one. Okay, again, this is 5. Letter S, you don't need it, and then question mark or X. Now the larger one, how did I get 9? I added 4 and 5, and I got 9, and 18 was already given to me. So now I'm going to create another proportion right here. Again, anytime, any way you want. I can go 9 divided by 5 this time. 9 over 5 equals, again, if I start from the larger one, I'm going to have to continue. 9 to 5 is the same thing as 18 to x. Okay, 18 over x. So that's how I created. You can mess around with other two numbers however you want. So again, 9 times x is the same thing as 5 times 18. All right, so again, let me write it down. 9 times x equals 18 times 5. Well, 9x, I don't know how to work this one, but because I don't know x, but I do know that 18 times 5 equals 90. So 9 times x equals 90. It's very convenient because all you got to do now is divide both sides by 9, since 9 is in here next to x. 9 and 9 cancel out on the left, leaving you just x equals 90 divided by 9 is 10. Again, it's a nice problem, and x equals 10. Let's take a look. Does that make sense if you put a 10 in here? Yeah, absolutely. It's less than 18, so if this is 10, then this is going to be 8. And another cool thing I just noticed, look, 9, 18. So this side is half of that side. 4, 8. 4 times 2 is 8. This one is twice as large as this one. 10 is doubles the 5. That's pretty cool.